Hello and welcome to another installment of Professor Wahoo's Basement Electronics, brought to you by electronicintegrity.net. And hey, so what we're doing today is we're going to be power testing a tube amplifier. This is a fairly new tube amplifier. It's a Fender amplifier. It's called a Custom Vibrolux Reverb amplifier. And it's sort of a classic design, uses two 6L6 output tubes. And we're just going to bench test it now and see what sort of power it can put out before it starts clipping. Alright? And I'm going to measure it two different ways. One, I'm going to use a voltmeter, and I've also got an oscilloscope connected because the oscilloscope lets me monitor the sine wave that we're going to be looking at, and also lets me do some more accurate voltage measurements if I want to double check everything. So what I've got here is I've got this thing connected into a testing system that I often use for stereo amplifiers. So it actually has two 8-ohm loads. So what I've done is I've plugged both of them in. So that two 8-ohm loads in parallel is a 4-ohm load, which is the ideal match for this sort of an amplifier. That's why you typically see them have two 8-ohm speakers wired in parallel in their speaker cabinets. Okay? So it's now going into a 4-ohm load, it's some resistive loads, and it's coming up to a basic monitor so I can monitor what's going into the dummy loads, and then I'll use this for more accurate voltage measurement. So I've got a signal generator generating a 1 kilohertz signal at minus 30 dB, a nice low level, going into the input stage, the bright channel. I've got all of the tone controls set on medium, on 5, and now I'm just going to start raising the volume. And we're going to start seeing a nice clean sine wave come up. So this is exactly what you want to see. Everything's nice and symmetrical. If one of these tubes were really failing, you would see either the top or the bottom look significantly distorted. And I'm getting a voltage reading now of up to 8 volts. I'm going to keep climbing up a little bit. We're up to, let's say, 10 volts now on the voltmeter. And the sine wave is still looking nice and clean. Now what happens with tube amplifiers is they will start to clip, but you get a nice smooth clipping at the top. So that's what we're going to go for. And I'm going to pause this for a moment so I can zoom everything in. Alright, so here we are zoomed in on the screen now, and I'm going to continue to increase the volume. And now you see it's starting to clip, it's starting to round off. It's still looking okay, and as a matter of fact, right now on my voltmeter, I'm reading 11.3 volts, which is exactly the spec they're looking for. So that's looking pretty good. It might be better with some fresher tubes, but that's reasonable. These are a fairly balanced pair of tubes that I've got in here. And I'm going to experiment and see if replacing the preamp tube helps any, but I don't expect that it will. This is probably limited by the output tubes. But there we go. We're getting a nice reading there of 11.3 volts on the voltmeter. Now I'm going to take a reading off the screen here. I'm going to readjust things just to make it easier to read. I'm going to put the bottom, I'm going to move it this way so that the bottom is on this little crosshair on my screen. And now I'm going to count my screen grid here and go up 1, 2, 3, 4, 5, 6 of those little squares. 6.5 squares, okay? And right now, this is at 5. The setting on my meter and all my dials is each one of these is 5 volts. So that's 5, 10, 15, 20, 25, 30, about 33 volts, let's call it, peak to peak. Alright, so that's what we've got there. And now, just to show you what happens if you keep going, if you keep cranking it, you notice the voltage doesn't go up a lot more. It just continues to clip. And this is the thing about a tube amplifier, is it will seriously clip for you, but it'll have a reasonably rounded knee, as they call it, as opposed to having a very angular edge, which is more common of transistor clipping. Alright? And when I max this thing out all the way up here, we're getting up to maybe 13.2 volts. Alright, so now let's calm the thing down, put it back into a more normal range, and let's look at some of those numbers. Okay, so one of the things about taking voltage measurements is they can be frequency dependent. Sometimes voltmeters like this have a little trouble getting an accurate reading over all frequencies, over all, we could even call it over all notes. So in theory, the oscilloscope is more accurate. So one of the things I wanted to check here is we had said that we had 11.3 volts AC being read by the voltmeter, and what we, at that point, when that was going on, we measured 33 volts peak to peak. Okay? And this is the 0 line going across the middle of the oscilloscope screen. And as the sine wave went up and down, you measured those peak spots, and that's why I moved it around a little bit so I could count the squares, multiply the squares by the setting on the dial, and figure out that we had 33 volts peak to peak. And if you look up your equations, and you'll find out that to convert peak to peak to RMS, to convert it to RMS voltage, which is what power is measured in, the units that are used for measuring power, you want to multiply that voltage by 0.3535. So when we take 33 times 0.3535, what we get is 11.66 volts RMS. So it looks like our voltmeter was reading a little low. In fact, we were probably getting a little more power at that point. So instead of going all the way up to here, we could back down and have a cleaner sine wave and still be meeting spec. Alright, so that shows that this amp is well within its spec range, and things are looking pretty good. I'm happy with that. Alright.